what we're going to do today is what we've actually done pretty much a lot of. We're just looking at it being proposed to us in a different way, okay? So we're going to be taking functions and working with them, and we have a couple different ways in which we can do that. You're going to see F and G a lot. That just stands for, like, F stands for function 1, and then G stands for function 2. It's like, hey, I have this equation, and I have this equation, okay? So, because you can't use numbers, okay, they use letters, and they've decided to use F and G, okay? So, you're going to see F and G a lot, but what it just represents is one represents something, and the other one represents something else, and we're just going to do what it asks us to do, okay? So, an example is, we have the f of x, so our f function, okay, which equals x squared minus 9. So that represents something, some mathematical situation, okay? It could have something to do with profits, it could have something to do with sales, it could have something to do with, you know, quantities, whatever. This represents something, right? And then there's another function called g of x, and then they label it g, okay, that it represents something else, okay? And these have something in common, and so you can work with them to create solutions. So, you know, if we create this many of this product and it costs this, and then but we only sell this many, how much do we make? And so this is something that is used a lot. We don't know the application behind that. Those taking AQR next year will learn what that is, okay? I'm just telling you that's kind of how we use it. So what we can do with them, we can do a couple things. We can add the equations, we could subtract the equations, we can multiply them, and we can divide them, okay? So those are all things that we can do with these equations, okay? When I see it, I'm going to see it as f plus g of x, and what that's saying is take my f equation and add it to my g equation, okay? So I'm going to take my f of x and I'm going to add it to my g of x, okay? So an example for this would be, well, let's take the x squared minus 9 and I'm going to add the x plus 3. So x squared minus 9 is my f of x equation, and I'm going to add it to my g of x, which is going to be x plus 3. Okay? Now this is something we've done many times this year, where we've taken two things and we've combined like terms. Okay? So all we do is set the functions equally to each other, or functions to add to each other, and then add like terms. So this should be total review. So I'm going to look for my x squared. I don't have any more x squareds, right? So that just becomes x squared. I'm going to look to see if I have any more x's. I don't. So I just have plus x. And then I look for my constants. I have a negative 9 and I have a positive 3. So that's a minus 6. And so that's all that's saying. And so you'll see this with the f plus g x. And that's just saying add the two functions. Okay? You have the same thing with subtraction, but you'll see f minus g. And what that's just saying is take your f of x function and subtract your g of x function. So whatever this is, you subtract that. So I'm going to take my x squared minus 9. I'm going to subtract, and this is, again, kind of goes back to making sure you are using your positive and negatives correctly. That is subtracting the whole thing, so each term needs to be subtracted. So I put in parentheses to know that needs to be applied to both. So that negative needs to go to that, and that negative needs to go to that. Okay? So then I rewrite this as x squared minus 9 minus x minus 3. Okay, so then you set functions to subtract, and then combine like terms. Right? So then I have x squared. I don't have any more x squares, so I just write that. I go to my next term, which is just x. I don't have any more of those, so I just do minus x. And I have a negative 9 and a negative 3, so that's minus 12. Okay? Good? Okay. So now, and again, you should see that as f minus g. That's how you're going to see that as. That just tells you take the function of f minus the function of g. So then we go to where it's multiplied. Hey, guess what we do? You put them together and multiply them, right? So we're going to do, it's like the f of x being multiplied by the g of x. Okay? So I'm going to take this equation, which is the x squared minus 9, and I'm going to multiply it, then what do I have with g of x, which is going to be x plus 3. So at this point, we need to do the distributive property, okay, where then I have to multiply to each one. So I'm going to do the x squared to x, which becomes x cubed. I'm going to do the x squared to 3, which becomes plus 3x squared. I'm going to take the negative 9 to the x and get negative 9x. And I take the negative 9 to 3 and I get a negative 27. At this point, I would look to see if I can combine like terms if possible, but it looks to me that all my terms are different because I have a cubed, a squared, a 1, and a 27. Okay? Now, what makes it a like term, you guys? Remember, a like term is the same variable with the same exponent. So I can't combine all these x's and make it x to the 6th. You can't do that. This is its own term, that's its own term, that's its own term. Okay? What's that? So then it's fine, it's done. Okay? So then I would just say combine like terms if possible. Okay? So division, again, so you'll see the multiplication one by f and then a little dot g of x. Okay? So now we're going to do f divided by g. So what do we have here? We have the f of x function, and we're dividing by the g of x function. So I could set that up as x squared minus 9, and that's divided by x plus 3. Okay? I'm not going to have you guys solve this one. What you want to do once you do this is you want to state what the domain, notice how it says state the domain. What can x not be? What can x not be in this? Nope.
Negative.
What can you not divide by? You cannot divide by 0, right? So what would make this denominator 0? Negative 3. So at this point you would say x cannot equal negative 3. So you write it out like this, and then you state what the domain is. Okay? Does that make sense?
How would you solve that?
Okay. Well, this one, the first thing you'd want to do is factor the top, because you can, right? So I would do x plus 3 and x minus 3. And I would divide by x plus 3. And these actually can cancel, so the solution becomes x minus 3. But it still cannot, x cannot be negative 3. So you basically need to know the x value it cannot be, because you cannot have that to be 0. Does that make sense?
So that would be negative?
What's that? This is the answer where x cannot equal 3. Negative 3, I mean. X cannot equal negative 3, because if x equals negative 3, then this comes out to be, you're dividing by 0. The answer would be this right here.
Oh, gotcha, okay.
Yeah.
Then if you solve it, you get x equals
Right.
x subtracted by 3, which is different from x equals
Yeah.
negative.
If it were like, let's say it was x minus 3 over x plus 3, let's say it was just like that, and you can't factor or cancel out, you would have to multiply by the conjugate. Do you guys remember what the conjugate is?
Plus or minus.
X minus 3. Alright, you'd multiply by its conjugate, and that cancels out the middle terms, allows you to factor, take the square root, blah, 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 blah. Remember all that good stuff? Okay. Okay. Alright, but we don't do that. Alright, so questions on when you see f plus g of x, f minus g of x, f times g of x, and f divided by g of x. Good? Okay. Would you like to practice one? Or move on?
Practice.
Practice? Alright, on the bottom here we go. We got f plus g of x. Okay? You have f minus g of x, f times g of x, and f divided by g of x. So, here are your equations. There's the f1 right here, and here's the g1. Okay? So go ahead and try and work them out. I'll give you guys about 5 minutes to see what you can get done. You have to recognize what's asking. It's f plus g of x, so it wants to take the f of x and add it to the g of x. Okay, so it's just saying take this equation and add to that equation. So I'm going to have 4x squared minus 2x plus 1, and I'm going to add a negative 5x. Okay? So I'm going to go and combine my like terms. I look for x squares. I only have the 1, so it's 4x squared. I have a negative 2x here, and I have a negative 5x here, so it's minus 7x, and I have a plus 1. So that would be your final answer there. Okay? Then it asks to subtract, so I'm going to do the f of x, and I'm going to subtract the g of x. So I'm going to take my 4x squared minus 2x plus 1. I'm going to subtract, and I always put in parentheses then, the negative 5x. Okay? This gets distributed to that, becomes a positive. So I'm going to have a 4x squared minus 2x plus 1 plus 5x. Combine my like terms, so I get 4x squared, I get a positive 3x, and I get a positive 1. Good so far? Then I'm going to multiply them. So I have f of x multiplied by the g of x. So that becomes my 4x squared minus 2x plus 1, and that's being multiplied by negative 5x. Okay? So at this point, I take this 5x and I have to distribute to each one. So the negative 5x to the 4x squared becomes a negative 20x cubed. The negative 5x to the negative 2x becomes a positive 10x squared. And then the negative 5x to the 1 becomes a negative 5x. I can't combine anymore, so that becomes my final answer. Okay? And then division is going to be my 4x squared minus 2x plus 1, and that's divided by my negative 5x. So that's the f of x divided by my g of x. Okay? If I'm able to cancel out, I could try. I don't have anything I could cancel out of these. There's not x's in both. If I factor them, it wouldn't work. So then you have to state the domain. So what you can do to make it easy if you don't see it is to just take whatever's in the domain and set it equal to 0. Okay, so I'm going to do negative 5x, and I make that equal to 0, and then solve for x. So I'm going to say x then equals 0 divided by negative 5, so therefore x equals 0. That is what it cannot equal to make it 0. So then you say x cannot equal 0. Okay? So if you don't see what it is, so basically what is the value that x cannot be? If you can't see that, then just set that domain equal to 0, the denominator equal to 0, solve for it, and then that is what it cannot be. Okay? Cannot be this.
Could it not be negative 5?
No, because negative 5 times negative 5 gives you a positive 25. Because you cannot divide by 0, so you're trying to find what makes the denominator 0. Okay? Whatever it is, it's not that. It's saying that this is the answer, but it can't be 0. Well, it's saying this is 0, and you don't want that. All right, flip. Okay. So that was working what we call function operations, adding, subtracting, multiplying, dividing, and now what we're going to do is dealing with what's called composite functions, and it looks kind of similar, but notice how the little dot in the middle is like an O. See that? Okay? And we call this f of g and then whatever that value is. Okay? And how this works is when you see this, now does everyone see the difference between that symbol and when it's this symbol, whatever the dot, that right there, okay? Yeah. This is a closed dot, this is an open dot, okay? So just realize that is the difference, okay? So if you remember, last class period, we saw something like this, P of 2, and then we had a P of x and let's say it says x squared plus 1, right? Okay? And what we did is we took this value and we plugged it into there and got an answer, right? Okay. So now we're doing the same thing. That is saying take g of 2, so take 2 for g, plug it into g and solve it, and then, but what it's saying then with the f in front of it is when you get that answer, then put that into f. So you could look at it very similar to something like f of g of x. So what it's saying is whatever I have here, solve it for g, and then take that value and then solve it for f. So it's kind of like you have one input, get an output, use it for an input, get an output. Okay, I know, it's like double the fun, and you didn't even know it, right? So, let's look at how this would be. If I have f of g of 2, I'm really saying take the f function and give me the answer of the g of 2. So I need to find g of 2 first, because we always work from the inside out, right? So I have to go g of 2. So I look to my g equation. This always tells you which one to look to. Take that value and plug it in. So I have 2 plus 3, because my g of x is x plus 3, right? So I'm going to take 2 and plug it in for there. What do I get? What's my answer? 5. So that is saying now I need to now take this and plug it into my f, because that answer is 5. So now I need to find f of 5, because this here then goes there. Okay? So whatever I have in the middle here goes into my equation. Whatever my output is goes into the f one. Now I take that value and I plug it into this, because that's my f equation. So that becomes 5 squared minus 9. So that becomes 25 minus 9, which is 16. Okay? And then that is the answer. Okay? So it's saying if I input 2 into my g function, that becomes the input to my f, which then gives me a value of 16. Okay? Does that kind of make sense? Alright, so now notice how it says g of x f of 2. So again, it's just the other way around exactly. So it's like g of f of 2. So I find 2 of f, and then I take that value and plug it into g. So I'll do f of 2, which then equals 2 squared minus 9, so that's going to be negative 5. I then take negative 5, okay, and that then becomes my input for g, so that becomes negative 5 plus 3, which then is negative 2, and that's my answer. Okay? Does that make sense? Alright. Now, you're going to try, you have 3 examples here. Now, notice this one on the right is f of 2. What is that saying to me? Nope. It's saying f of 2, this one here. This is saying you plug it in twice, right? So you find f of 2 first, and then whatever that value is, you go back and plug it into your original equation again. It's double the fun. Alright, so I'm going to give you guys a couple minutes to try that. Go for it. So, on this one here, the answer is 421. Okay? Did you guys get that? So how do we work is it becomes f of g of 2. So we work from the inside out, so I got to put 2 in for g. So the g of 2 equals negative 5 times 2, which is negative 10. Then I take that value and plug it into f. Okay, so then this becomes that. So then I have, bless you, 4 times negative 10 squared minus 2 times negative 10 plus 1. This is 400, this is plus 20, this is plus 1. Okay? Good? Alright, next one. This is like g of f of 2. So I'm going to take the 2 and plug it into my f. So f of 2 equals 4, 2 squared, minus 2 times 2, plus 1. So this becomes 4 times 4 is 16, minus 4 plus 1. So that ends up being 13? So then this becomes g of 13, because that goes into there. And so therefore that becomes negative 5 times 13, which then is negative 65. Okay? Question so far? Alright, and then the answer for the last one is 651. Did everyone get that? Okay, do I need to demonstrate or are y'all good?
Can you go over?
Okay, so I have, this becomes f of 2, so this is going to be, the first f of 2 is going to equal 4, and then you got 2 squared minus 2 squared, or times 2 plus 1, so this is 13, right? Then I got to take this value and put it into f again. So I do f of 13, so that's where I go 4 times 13 squared minus 2 times 13 plus 1. So this is like 169 times 4, and then you minus 26 and add 1, and in the end that should be 651. Okay? Good? Okay. So we have just, when you see the open dot, so we're all good with the closed dot, open dot, right?
Yes.
And then when you see numbers, you see it as take the value here, get your answer, and then plug it into the one that's to your left. Okay, we're all good with that? Okay. We're doing the exact same thing on the bottom. However, what do you notice different about the bottom?
There's not a number.
There's no number. Right, there's no numbers.
Yeah.
Okay, so what this is saying is you're going to take whatever g of x is and you're going to put it in to where you see x of f. Okay, so what I'm doing is the same concept, but I don't have an answer, I don't have a number answer for g of x, do I? Because there's no number there, right? It's a variable, right? You guys all get what I'm saying? So therefore, I'm just going to take what this is and I'm going to plug it into where I see x here. So this is all like a plug and play, you guys. This is all take what you have, put it into something else. Take what you have, put it into something else. If I have a numeric answer, I put it in. Solve, take it, put it in. If I don't have a numeric answer, I'm just going to take what the value is and plug it in, right? Okay. So what is my g of x? My g of x is 2x plus 3, or minus 3, right? So I'm going to take whatever this is, because there is no number, and I'm going to put it into my f of x. So this is the f of g of x, okay? So wherever I see a g of x, I'm going to plug in that. So here I have x squared. Well, x squared really is going to be this value right here, okay? So I'm going to rewrite this out for a second, and I'm going to just, hold on, I'm going to do this. And what this is saying is wherever I see an x, I'm going to put my g of x. Wherever I see an x, I'm going to put my g of x. So whatever that equals goes there, okay? So this becomes rewritten as x squared is going to now be 2x minus 3 squared, because that equals that now, right? It's saying take this and plug it in there, okay? Then I'm doing minus 3, well I see an x, so I got to put the value of g of x in there, and that's going to be then 2x minus 3, and I do plus 1. So you're doing the same thing, it's just that we don't have a number for g of x now, do we? Because that's what we were doing before, we're just putting a number in, but we don't have a number, so now we're going to throw in what that actually equals.
So if it's g of x, that means we would just replace
the whole
it with
equation
2x
as
minus 3.
Yeah, so when you see g of x, you're taking wherever you see x. So normally, like let's say it was g of 4. Well, you take whatever that value was and you'd be plugging into the x, right? We don't have a value, so the whole equation gets dumped in there. Okay?
All right.
So you're doing the exact same thing, it just looks more confusing.
We
Cause
used to do that. Isn't that something else too when it's on like S, X, and Z?
yeah, so you guys have done this before, you just haven't seen it in this way. And it hasn't been that complex, okay? Alright, question.
Do you distribute the negative and 3?
Yeah, I'll walk through solving it.
Okay.
Yeah, Brad, question? Question?
Yeah.
Alright, so now, is that your answer? No, you need to then simplify it as best you possibly can, okay? So, you have to do the following. which is kind of a pain in the butt on this one, but this becomes 2x minus 3 times 2x minus 3. This then gets distributed like this, so it becomes a negative 6x, a plus 9, and then a plus 1.
What happened to the square?
That's it right there.
You did it.
Yep. Okay, so you have to then go and simplify it as best you possibly can. So then I'm going to distribute this right here because I can. So that becomes 4x squared. Okay, this becomes a negative 6x. What's it? You are dealing with this right here. This is saying the 2x minus 3 is being multiplied twice. That's why I'm doing it twice like this. You don't square this and then square that. Remember, it's this times this. A squared means this item is being multiplied by itself twice, right? A cube means it's being multiplied by itself 3 times. So you have to multiply it that way and distribute. Okay? So then, again, that's 4x squared minus 6x. This would be minus 6x. And then this would be plus 9. And this becomes minus 6x plus 9 plus 1. So then that's where you have to squish all like terms. Okay? So how many squares do I have? I just have 1, so it's 4x squared. I feel like I'm running out of room, so I'm going to write it up here. So it's going to be 4x squared. So you look for all your x terms. I have a negative 6, a negative 6, and a negative 6. So it's minus 18x. And then I have a 9 and a 9 and a 1, so that's plus 19. And hopefully I did my math right.
Wait.
That's right. I think that you're right.
Okay? So, what's that?
Because you're taking all those 6 x's and putting them together.
There's a 3x times a 2, a negative 3 times a 2, a negative 3 times a 2, and then a negative 6 there.
Spoil it. And
Okay? Alright, questions on that? Alright, so let's do this one over here where it's g of f of x. So there's no number, so I'm taking the value of f of x, and I'm going to plug it into g of x. So my g of x is the 2x minus 3. So wherever I see x, I got to plug in this whole thing here. Okay? But it's only 1, so that's not bad. So my g of f of x is going to equal 2 times my f of x. So that's going to be x squared minus 3x plus 1 minus 3. Okay, so this is my f of x right there.
So you can plug that.
So you could, actually it's a lot easier than it looked. It seemed like, right? So now I just have to distribute to each item here. So this becomes 2x squared minus 6x plus 2 minus 3. So I can combine like terms. These are the only ones I can combine. So I got 2x squared minus 6x minus 1. And that equals my g of f of x. Isn't that kind of fun? I think it's fun. Because it's not like a difficult concept. It's like plug and play. Look at that. I got an answer. I don't know. Okay. Here we go. So this is going to be the fg of x. So I'm going to take whatever is g of x and plug it into f of x. So I got x squared, so I'm going to put x plus 3 squared. I got plus 2x, I'll do plus 2, put in x plus 3. And I got, that's it. So now I want to just go ahead and do the basic math of this. So that's squared, so that gets multiplied twice. And then this gets distributed this way, so it's 2x plus 6. So this becomes x squared plus 3x plus 3x plus 9 plus 2x plus 6. And when I combine all my like terms, I get x squared, I get plus 8x, and plus 15. Y'all get the same answer? If not, did you at least get it set up correctly? Alright, sweet. This one is nice. I like this one, right?
That's the final answer right there.
That's the final answer. So this one's just going to be wherever g of x is, wherever x is I plug in that. So I got x plus 3, so where x is I'm going to do x squared plus 2x. That's my x, and then it's just plus 3. I can't combine any like terms. Done. that nice?
How did you get 8x? Because the 2 is positive?
3, 3, and 2.
Why
Yes.
is the 2 positive?
Because it's plus that.
It's plus. But
Okay.
even when it is, oh,
So cross out the very bottom, we're just going to go here. We're going to be talking about what's called inverse relations, and we're just really tapering it down. Pretty much, also on your homework, skip 33 through 35.
Oh, wait, can we do this too?
Well, I'm going to actually cutting this down today. We're only going to do this page, which literally is super
so
easy.
you have 2 sets of homework.
Yeah, well, you have 1.5. You 1.5.
So how many, for this one,
We're going to be looking at what's called inverse relation and functions, and you guys do, for whatever math class you're going to next year, you're going to be using this, so that's why we're introducing it. Basically, when we talk about what is a function, if you guys remember way back when, it's basically where each element of the domain, okay, maps to one element of the range. Okay? And you cannot have multiple what? Domains. Okay? So that's a function. So you will not have repeating domains. Okay? Now, oh yeah, sorry. Okay? So that's a function, right? So when you look at right here, this example, notice how there's no multiple x's. Okay? You can go to multiple y's, you can go to multiple ranges, but you will not go to multiple domains. Okay? If a domain branches off, that is not a function.
What does that mean? Each element of a domain maps to...
So basically, you will not have multiple domains. You will not have multiple values, the same value of x going to different things. Okay? So the inverse of that, so it's the reverse. Okay? The inverse is what we call reverse, and I kind of don't have a lot of space on here. So we call it the reverse. So basically, when x equaled y, the inverse is now where y is going to be x. Okay? So if you are given a function point of x and y, its inverse is just the flipped coordinates. So if I give you a coordinate of 1 and 2, 1 comma 2, I say what's its inverse, you would say 2 comma 1. Okay? So it's just FYI, my note sheet's a little bit different than yours. If the inverse, so basically then if the inverse is also a function, meaning that once I flip it I don't have any repeating values, we're going to denote this as f of x, but you have it to the -1 now. So if you see f of x to the -1, that means you're talking what is its inverse. Okay?
So, do you mean like, if you can flip it and it's still like different numbers or different?
So here's an example. So
would it not be a function that moves like 1 and 1?
yeah. So let's just look at something. Let's say I have 2 points. We're going to go through this more, but let's say I have 2 points of 1 comma 2, 2 comma 3, and 3 comma 4.
There's none
Okay.
on the left.
So this is a function, right?
Yeah.
Mm-hmm.
Because there are no repeating x's, right?
Yes.
So let's look at its inverse. The inverse is going to be 2 comma 1, 3 comma 2, 4 comma 3. That's its inverse, right? Because I just flipped it. Are there any repeating x's at this point? No. So this is also a function. Okay? So this would be the...
If there's the same range on 2 of them, then it won't.
Right. Right. So now, let's say I have 1 comma 2, 2 comma 3, and 3 comma 3. Okay?
There's no function.
This is a function here, but when I do the inverse, which is, oops, down here, it would not be because I have a 2, 1, a 3, 2, and then I have a 3, 3. So therefore, this is not a function. Okay? You guys get what I'm saying?
So it's not f of x is the...
Right. Right. Exactly right.
F of x is negative 1 is the inverse.
Right. Yes. Okay? So now, let's look at these points here. It says, find the inverse and graph. So let's just graph what this looks like, just so you kind of can see what happens. I have 0, negative 1. So I'm going to go 0, negative 1. I have 2, 0. I have 3, 2. And then I have 4, 3. Okay? So it looks something like... Did I graph that right? Yeah, it's kind of, this is what it looks like in general. It's going to look something like this. Okay? So now, let's write its inverse. So its inverse is going to be negative 1, 0, 0, 2, 2, 3, and 3, 4. Okay? So I'm going to graph that. I'll use different colors. So I'm going to go negative 1, 0. Oh, sorry, it's the wrong way. Negative 1, 0 would help if I did it right. 0, 2, 2, 3, and then 3, 4. Okay? And what you're going to notice, which I don't know if I really did this very well, is that it's going to look something like this.
A little higher and like kind of opposite.
It's a mirror. It should be a mirror of it. And it then should actually, and I don't know if I actually plugged those all out right, but it actually should mirror right here the y equals x axis. So that's what an inverse is. It's like the mirror image off that axis. Okay? Does that make sense? So you want to be able to, when you see these points and it says, okay, number 1, what's its inverse, be able to flip them. Okay, so where it was x, y, it now becomes y, x. In regards to the values, these are then x and y too, but now it's like a new one. Okay, and then it's a function if the domain never repeats. Okay, and here this is a function because there's no repeating. This is a function. Okay, so if you can do that, then we call it it is the inverse of the function. If it doesn't, if it has the repeats, it's not an inverse of the function. Okay, right? Yeah, it will have issues. So let's look at this. It says find the inverse of each relationship. So let's do the inverse. Okay. So if I have 1, 2, what's the inverse of that? 2, 1. If I have the inverse of 4, negative 2, negative 2, 4, right? And then 3, 2, the inverse is what? 2, 3. Okay. So is the top one a function? Yep. Is the bottom one a function? No. So this is not an inverse. Okay.
Well, it's not functional.
Well, this is not an inverse of that function. This is not an inverse of that function. Okay. So let's look at this one. What's the inverse of negative 2, 4? 4, negative 2. What's the inverse of negative 4, 3? And then what's the inverse of negative 5, 8? Negative 8. I just gave it to you. Negative 8, negative 5 is then negative 5, negative 8. Sorry, I just gave you the answer. Alright, so the top one, is it a function? So this is a function. Is this the inverse of a function? Yes, it is, because there's no repeating. So this is, yes, it's an inverse of the function.
The first A is not an inverse.
This one is not an inverse because there's repeating. It is a function because there's no repeating. It is a function. This is a function. But it's not an inverse of it. Okay? All right.